Okay, let's take a quick review about what we covered in the last lecture. Last one is decision theory part 1, and what I covered today is part 2. But let's review what we did for the last lecture. Decision making without experimentation. Okay, recall we have 4 criteria for decision making: maxi max, maxi min. These two without probability. When we make a decision making for maxi max or maxi min, we did not use any probability distribution at all. And these two, we use probability. Okay? So this is what we covered last time. Okay? What we covered last time. Starting today, we cover decision making with experimentation. And this is a payoff table we looked last time. Okay, let's go over this again. There are two states of nature, S1 and S2. S1 is what? Underground, you can find oil. S2, underground is dry. Alternatives, or you say action. Action 1, 3 for oil. Action 2, sell the land. Okay? If the decision is drill for oil, and you can find oil underground, the company earn what? 700,000 profit. But if underground is dry, the company will lose what? 100,000 for drilling cost. Okay. Now, compared to action 1, if make decision as what? Sell the land. Then doesn't matter oil underground or no oil underground. The company by selling the land always get what? $90,000. The prior probability you can find oil underground is about 25%. No oil underground, 75%. Okay? Now, as I mentioned last class, how do you know this number are reliable? Sometimes this probably based on the previous what? Drilling experience. Not necessarily apply to this case. So we want to get more evidence. Okay? From getting more information, we may be able to adjust those prior probability to get a more accurate estimation for this time. And that kind of probability is called posterior probability distribution. Okay? These are called prior probability distributions. Is this number good enough for decision making? Because this involves a big amount of money. If this is wrong decision, the company can lose a lot of money. So they want to get a better distribution or get new evidence to modify those distribution and leading to more accurate what? Estimation on there's oil underground or no oil underground. Okay? So decision makers may want to get a better estimation based on some more what? Advanced data. Okay? Or some more new data. New and advanced data. Okay? And after that, they can use those new information to modify the probability distribution. In this case, we call that kind of probability distribution, we call it posterior. After you obtain new evidence, you get better estimation on probability distribution. We call that kind of probability distribution posterior probabilities. Okay? So in order to get new evidence, the company decide to do what? A seismic survey. To do a seismic survey, they need to hire an expert. And they need to dig out the soil underground. Okay? And for those information, they can modify the prior probability distribution. Okay? But hire an expert, there will be a cost of $30,000. And they want to know, is that worthwhile? Hire expert and pay $30,000 so they can get what? A better probability distribution. Okay? That's a second concern after they decided to do what? Sesame survey. They this action will involve with new cost, and they just wonder, is that really worth it? Okay. After conducting what? Sesame survey, there are two possible findings or two possible outcomes. First one is unfavorable sesame sounding. Unfavorable sesame sounding. That means oil underground is very unlikely. That means most likely underground is dry. Second possible finding, favorable sesame sounding. That means oil is very likely underground. Okay? So after you hire expert to do a sesame survey, right? They dig out the soil underground deep enough, and they put in the laboratory to analyze the ingredients in what? In those soil, and try to figure out how likely underground can be dry or can be what? They can find oil underground. Okay? That's called sesame survey. Now, two possible findings. Um, from the past, from past what? Industrial record. Okay? This is a record in industrial. Open information for everybody. Okay? For example, let me explain those numbers in the table. When there is oil underground, this is a state, right? State is oil underground or dry. When there is oil underground, how likely the expert will advise you what? There's what? Favorable sesame sounding. Okay? When underground is what? Is oil. How likely you spend money, hire expert, and that expert tell you, yes, it's favorable. Okay? That chance is 0.6, or you say 60%. Only 60%. But for example, when underground is dry, no oil underground, how often, historical record, how likely the expert will advise you don't do it because it's unfavorable sesame sounding. This one is 0.8. That's 80%. Okay? So this is not that convincing because when you flip a coin, it's 50%. Okay? But this one is crucial. When there is no oil underground, most likely 80% chance, the expert will say don't do it. Okay? Unlikely what? Unfavorable sesame sounding underground. So when there is dry, the money you spend on the expert, that expert will advise you don't do it. Okay? So for that reason, that's intuition. Hiring an expert to do what? Sesame survey is a good idea. Okay? So let's look at the numbers here. Two probabilities. First one, look at these two conditional probability. This one says when there is oil underground, how likely expert will tell you favorable. This one, when experts say it's favorable sesame sounding, how likely you can really find oil underground. Among these two conditional probability, which one is more useful for decision making? Okay, let me try one more time. These two conditional probability, let me rewrite like this. A given B versus B given A. In our example, when there's oil underground, how likely expert will suggest is favorable sesame sounding? This one is when expert tell you it's favorable sesame sounding, how likely you can actually find oil underground? These two conditional probability, which one is more useful for decision making? Think about it. Okay, you have what? You have 30 seconds. Think about it. Coming back, I'm gonna ask you. When expert, this vertical bar means given that expert tell you is favorable sesame sounding based on his or her judgment. How much you should trust it? There is oil underground. The expert suggests underground very likely can find what? Oil. Based on his or her advice, probably you can find oil underground is what? As I mentioned earlier. If this probability is big, then this means what? It's more reliable, right? So among these two, 1 and 2, which one is more useful for decision making? Answer is what? Answer is 2. Because when you make decision, you hear the advice from what? Expert first. Okay? If expert say favorable sesame sounding, use that information. You're going to make decision whether there's oil underground or no oil underground. Okay? So it's 2. Okay? But this is available in historical data. When there's oil underground from the history, they have a statistic. How likely expert will say the right thing, right? But which one is more useful decision making? Because when you spend money, every time, based on the Sesame survey, the expert will come back to what? Give you information. Favorable sesame sounding or unfavorable sesame sounding. Based on that, you need to make decision. So this one is more useful. But this is available what? In historic data. Okay? So this is available in historic data. That means this you can find from the table. But this one you cannot find from the table. But this is more useful for decision making. So you need to use base decision. You need to use what? Base zero to find out this more useful what? More useful what? Probability distribution. Okay? And the method to find this probability distribution, we call it base what? Base zero. Listen, it's base zero, not base decision rule. Okay? Okay? So this is a conditional probability. Since you spend $30,000, you hire expert. The expert, after doing what? Sesame survey in the lab. He or she will come back to tell you what he think about what? The situation underground. If he say favorable, that means very likely there's oil underground. But if he say unfavorable, then very likely underground has no oil. So what is important is this distribution, okay? This distribution, this probability distribution, not this one, okay? Not this one. So for that reason, if you find oil underground, this is called prior. And after you hire expert to do what? Sesame survey, he or she will come back to tell you the situation, what he think about the situation underground. If he say favorable seismic survey, that means his opinion. Huh? He think there's oil underground. And based on this, you're going to make decision. You're going to sell the land or you want to what? Drill for oil. Okay? So this is more useful. But this is not available. So how can we find this so-called posterior distribution? Okay? Posterior means after you do what? Huh? Do a seismic survey. You got new information or new data or new evidence. You can modify the probability distribution you find oil underground. And that will be more accurate than what? Prior, just oil. Okay? This is based on more evidence. This is not. So this is called prior. This is called what? Posterior. And we're going to use Bayes theorem to find the posterior probability distribution because we're going to use that to make decision. Okay? Let's look at here. We're going to find the posterior probability distribution by using what? Bayes theorem, not Bayes decision rule. Okay? And this is from the previous industrial record. When underground is oil, the expert predict what? Unfavorable. It happened 40% of times. When there's oil underground, the expert predict or forecast is favorable 60% of time. This is not very promising, okay? Even you flip the coin, it's about 50%. But when you flip the coin, you don't need to spend any money. I think the feeling is here. The intuition is here. When experts say it's dry, 80% of the time, they are right, okay? They will say what? When underground is dry, 80% of the time, the experts say unfavorable. So based on this one, you should hire what? You should hire expert to do the seismic survey. Okay. So this is from historical data, but for the decision making, we need this. Okay. When expert coming back to tell you unfavorable, how likely there is actually oil underground? When expert come back to tell you unfavorable, how likely it's right? Underground is right. Or when experts come back to tell you it's a favorable seismic survey, how likely they are right? You can actually find oil underground. This is more useful for decision making. So we're going to use Bayesian, okay, Bayes theorem to find what? Those posterior distribution. Okay, I'm going to find just two, and the rest can be derived easily. So let's look at the definition of conditional probability. Okay, we say probability A given B by definition is probability A and B over probability B. So this one just copy the same thing in the numerator. Probability of B can be decomposed into two components. B, this is the whole sample space omega. B is the red shaded area. But A and A complement, this first piece is A and B, okay? A intersect with B is this piece. And A complement intersect with B is this piece. So B is equal to A and B, which is this part, together with what? With this part, okay? So probability B can be written as P A and B or A complement and B. So by formula, P what? E and E or F is PE plus PF minus PE or F. Okay? Sorry, this is E or N F. Okay, this is or, this is N. So follow the formula. Basic probability rule number 3. This is P, A, and B. Plus P, A complement and B. Subtract by intersection part. But A complement, they share nothing in common. So this is what? Empty. Probability on an empty set is 0. Okay? So this explains why the formula look like this. PB can be decomposed as PA and B plus PA complement and B. Okay? We're going to use the formula to find what? Huh? The posterior probability distribution. First one, let's look at when expert come back to tell you unfavorable. Huh? There's actually what? Or you're underground. That can he make a mistake. Okay? So let's first find this probability. When experts say unfavorable says me something, how likely he's wrong? We can actually find all underground. By what? The definition of conditional probability, we can write this one as Euler and what? Euler underground and experts say unfavorable. And this one is unfavorable. Says me something. By using the formula, we can write this one as 2p's. We can decompose into 2 parts. You can find Euler underground and experts say unfavorable says me something. Plus, underground is dry. And experts say what? Unfavorable says me something. So we're going to use conditional probability. Look at here. Probability A given B is PA and B over PB. So that is to say P, A, and B can be written as PB times probability what? A given B. Or you use similar probability B and A. You can get another formula. That is PA times what? Probability B given A. Okay? So we're going to use this formula to evaluate here. Okay? Find all your underground and experts say what? Unfavorable says me something. I can write as okay? This is actually equal to this. And the rest work, just plug in the numbers. Okay? How likely underground has all year? That chance is what? 1 over 4. But when there's all year underground, how likely the expert advise you are correctly? This is from what? Industrial record. When there's all year underground, experts say what? Unfavorable. That happened 40% of time. Okay? So you times 40%. So this one repeat. They are the same thing. 40% times 1 over 4. Plus, how likely underground is dry? That's 3/4. This is a prior distribution, 3/4. Okay? And when underground is dry from historical record, how likely what? Expert is correct. Okay? Underground is what? When underground is dry, how in the industrial record, how often expert advise you what correctly? Unfavorable. Okay? So this is what? Here this is 80%. So you just plug in the numbers. And after you simplify, you can get what? You can get the answer. Okay? So from the previous page, we find when expert advise unfavorable sesame something. Okay, 1 out of 7 times. He is incorrect. Okay, incorrect. So this is from the calculation. We use base 0 and find this answer. Now, if we find this, then we know probability that unfavorable sesame something, and this is right, should be 1 minus 1 over 7, which is 6 out of 7. Okay, now let's look at the other one. When expert come back to tell you favorable sesame something, how likely you can actually find oil underground? This one, again, we're going to use base 0. Okay, this is going to be oil and what? Favorable sesame something. And this is same thing, right? This is favorable sesame something. And you can decompose this into 2 parts. Favorable sesame something, and it comes from what? Find oil underground. Or favorable sesame something, but actually underground is what? Dry. This one, just copied it. Okay, and then we can rewrite it in terms of what? Historical data. Okay, historical data. When oil underground times what? Given there's oil underground, how likely experts say favorable sesame something? This is available from industrial record. Okay, and this is dry underground times what? Given it's dry, how likely experts say favorable sesame something? And this are the same. So I copy this one on the top. Okay, and then you plug in the number. This number from historical data. Okay, and there are the prior probability to find oil underground is what? Is 1 in 4. When there's oil underground, and expert advise what? Favorable sesame something. That is what? That is 0.6. Okay, that is 0.6. So this one repeat. And plus, how likely underground is dry? 3/4. When underground is dry, how often experts say favorable sesame something? Dry, and experts say favorable sesame something 20% of time. Okay, after you combine them together, what do you get? You get what? You get 1 in 2. Okay, you get 1 in 2, 50% chance of the time. Okay, and that is to say, what is favorable sesame something? And actually, experts say favorable. How likely they are wrong? Underground is actually dry. This is equal to 1 minus 1/2, which is also what? It's also 50%. Okay, so let's write it down again all together here. Okay, so look at here. This is a prior probability distribution. Okay, probably your feeling or probably from what? The previous owner. They told you they think 25% chance you can find oil underground. 75% chance underground is dry. But Are you really want to spend a lot of money for those probability distribution? Maybe not that accurate. So you want to hire expert to do what? A little bit more job on the soil condition underground. Okay, if you do seismic survey and experts say unfavorable, how likely they are wrong? 1 in 7. And when experts say favorable, 50% chance they are correct. Okay. Now, when this is what they come back to tell you unfavorable, you better listen because we find by base zero, 6 out of 7 times they are correct. Okay. And when they say favorable, actually underground is right, it's 50%. Okay. This is what the probability you can find oil or dry underground. But this is based on what? Extra seismic survey. You get new evidence. Therefore, you modify what? The underground condition. You get a more accurate distribution. Okay? That's posterior. Now, let's proceed. After we find what? The posterior probability distribution. And the company decision maker going to check or make a decision whether to obtain more information by hiring and after getting the posterior probability distribution, the decision maker want to know whether they should what? Hire an expert to obtain more information. Okay? And remember, hiring an expert, the company need to pay what? $30,000. Now, first one, expected payoff. This is expected payoff without more information. That means if they don't hire what? If they don't hire an expert to do seismic survey, this is same as a base decision rule, not base zero. Okay? So let's look at the table here. If they take what? Action 1, expected payoff of taking action 1. Okay? 3 for oil. If they find oil underground, the profit is 700,000. But how likely they find oil underground? That is what? 1 in 4. And they're going to lose 100K if there's no oil underground. As we studied this before, this is going to be equal to 100K. And what is the expected payoff if they take action 2? Sell the land. Sell the land is no risk. Doesn't matter you find oil underground or no oil underground. It's always 90K. So that's 90K. Which one is the bigger one? The max of the two, 100K, 90K. Of course, this is a bigger one. And the bigger one actually coming from what? Take the action 1. This decision procedure is a base decision rule. We covered this last class. Okay? So if you decide not to take any extra information, don't do seismic survey. The expected payoff is just 100,000. Okay? This is the same one as you get from what? Base decision rule. Now, what's EP expected payoff with perfect information. Okay. That means you go ahead to hire expert. Okay, and do what sesame survey. But even this person is very smart, almost as smart as God. God knows everything. Okay, that means perfect. So look at the payoff table. Look at the payoff table. You hire expert, a very what? Smart expert, very intelligent expert, as smart as God. Okay? So when God tell you, there's oil underground, what's your decision? You go to 3 for oil. But how likely God will tell you there's oil underground? Huh? 25% chance. You hire expert, as smart as God. Okay? So how likely, huh? If God tell you there's all the oil underground, so you go to 3 for oil, okay? So that's 700K. But how likely God will tell you there's oil underground? That chance is only 1 in 4. So if God tell you there's no oil underground is right. So you're gonna sell the land, okay? But how likely God will tell you, huh? Underground is right. That chance is what? That chance is 3 in 4. Okay? So you can actually calculate the number. That number should be that should be 242.5K. Okay? And let's look at the last term. EVPI. EVPI. Okay? What's EVPI? EVPI is defined to be EP with perfect information. Subtract by EP without more information. So according to our early discussion, EP with perfect information is 242.5K. Subtract EP without more information. That is what? That is 100K. So the difference is going to be 142.5K. And this number is very important for decision maker. Look at here. EVPI defined to be EP with perfect information subtract by EP what? Without more information. Think about this. What does this one tell us? So think about this. EVPI is a very important index. What can you learn from this number? 142.5 is that if expert asks you, huh, you need to pay amount of money more than this, you are not going to what? Do the sesame survey. Because even you hire a very smart expert, as smart as God, the extra money you can gain from not hiring expert is at most what? 142.5K. So if the expert asks you, he gonna charge the money more than this amount, you are not going to what? Hire the expert. Okay? So if EVPI greater than the cost of hiring what? of hiding the expert. Then what's the decision? EBPI greater than cost. Okay? Decision is what? Huh? It's okay to hire expert. But if EBPI is less than the cost, even you hire expert, the money you're going to spend is greater than EBPI, then you don't want to hire expert. Okay? Okay, next topic. We're going to show you how can we draw a decision tree. Okay, decision tree. To then use the decision tree to come up with the optimal decision or optimal strategy. So let's give you a very simple definition on what is a decision tree. A decision tree consists of nodes and arcs. Okay, let's begin with nodes. If you put a square nodes, it's a decision nodes. Decision nodes followed by decisions. And you put a circle, that means event nodes. And event nodes followed by what? Random events. So we're going to see probability. Okay? That's a big picture. And then we're going to come for what? More detailed description on the how to make a decision tree.